this class. If you need to get into Google Meets, you should go ahead and do so now. If you need to be logged into Google Meets to see what's on the screen. I'm going to go ahead and get started. First thing is with class announcements, just to remind you on what's going on. Please make sure at this time independent work is over, so take your headphones out. That's standard procedure, so I know that you're listening to me and that you know what's going on. All right, thank you. So, first off, remember there's a board over there you can look at whenever you want to know what's going on. If you are missing a class period, you want to know what's coming up. There's a board that I do update on a regular basis. As you can see, it says Electron Configuration Day 2 on today's lesson. Today is the last lesson of this topic, which is filling electrons into atoms. So that means that the penultimate, what you're going to need to be able to do, you're going to do today in that lesson. The next thing is that next class period, you are going to have a lab. It's going to be in the second half of class. So the last hour of class, you will be doing the flame tests lab. Like I said last class period, and I gave you a big notice on this about a week heads up, next class period, you need to bring a hair tie, and you need to make sure you're wearing closed-toe shoes. So if you are wearing Crocs, which some of you are today, if you are wearing Crocs, you will not be allowed to do the lab. You will have to do something else, and it won't be fun, and it'll be an essay or something that you will have to do for a grade. So wear proper attire, or you will not be allowed to do the lab. This is a warning. No, it's next class. It was next week, last week. It's next class. You have a lab. Wear proper attire. This is one thing that a chemistry teacher will get on you for. I've been telling you since the beginning of the year. Make the note for yourself that you need to wear proper attire and bring a hair tie for that lab next class. Yes, that's why you need to make sure everybody's listening. If you aren't, like I said, you're going to be given an alternative assignment. It will not be fun, and it will be a grade that will go in the grade book. And it will not be a team project. It will be something you have to do yourself, and you will likely be sent to another teacher's classroom for the entirety of the course period during the laboratory. So make sure you're in proper lab gear so that you get to do the lab. All right, so that was for next class. And then on Friday, you are going to have a quiz on the topic with the topic that ends today. So for quizzes, how I've been doing this year is the first part of the class will be review, and the last 30 minutes will be the quiz. And I'll talk more about what that quiz is going to look like next class, but expect it to be around 15 questions, multiple choice, and 5 points written for a total of 20 points. The written part will look like the homework today. Just as a heads up. It'll look like the homework today, but it'll be a different question. No. The homework you received today. Because today's the last lesson, so it's the penultimate of what you need to be able to do for this first half of the content in the unit. All right, so here we go. Let's get started with the new material. I'm going to go ahead and get out of the intro slide. And into the lesson. So we are Unit 2, Lesson 3, and this is the final lesson of the first half of this unit, and we are going to finalize how we're going to fill electrons into atoms today. And so it says electron configuration continues. Last class, we did how to fill electrons into energy levels and into sublevels, sublevels being S, P, D, and F. Today, we are going to furthermore be able to fill electrons into individual orbitals. And then we're going to learn how to use the periodic table to do these electron configurations. You don't have to memorize the entire order off the top of your head. So that handout from last class, you may want to have it out with you again, because we'll be going back to that as we do orbital configurations in a little while. So once again, you may want to have that handout from last class, so we are all on the same page. Make sure you're writing the title to the lesson, Unit 2, Lesson 3, Electron Configurations Continued. I am recording in this class, and we're about to get started. this is what we went over last class. We spent a long time going over the order and how to fill electrons into sublevels properly. And so what we're going to see today is how to fill electrons into the individual boxes, basically. To the individual. No, absolutely not. You, like I had said last class, you will have to know everything that's on here. However, with a periodic table, you will get much of this from the periodic table itself. So the only resource you will have on the quiz next on Friday is going to be that laminated periodic table, and you're going to have to be able to utilize that to come up with your electron configuration. So you're going to need to make sure to pay careful attention, because like I said, today's the lesson that kind of like brings it the rest of it together. What you're going to need. Now we went over in this class. We went over ions last class. That ions, cations, you take away electrons, and anions, you add electrons. So I'm skipping this. Some of the other classes that have some more interactions, I had to wait. And we also went over this last class, which is spin, electron spin. So what you need to know, and I think I had you do this last class, but on your diagram, if you haven't already, you should write electrons as arrows up and down. So in the orbital diagram, electrons are written as arrows that go up and down. There were 3 rules that we used last class. 2 of them we actually only used. We didn't use the 3rd one yet. That tell us how to fill electrons properly. Those rules are you fill electrons from lowest energy level to highest energy level. The second one is 2 electrons fit into every one orbital. And the third is the one we're going to look at today. When you have orbitals of equal energy, you put 1 electron in each box first before doubling up. So you maximize your positive spin. That's called Hund's rule. We're going to be looking at that today. So actually, we're going to jump straight into it. It says electron configuration practice number 3 because this is continued from last class. Orbital diagram configurations boxes. So it says write the orbital diagram. Go ahead and write this out and write out the instructions. Write the orbital diagram electron configurations with following that. Write A and then leave yourself space to see how much space it will take you to do this, and then we'll do A and B here. Again, you're going to want to have this handout with you to help guide you in the process of what you're going to do. And so I'm underlining that word orbital diagram because you need to recognize whenever you see orbital diagram, that means you're going to be filling electrons into boxes. And those boxes represent the individual orbitals, the s orbitals, the p orbitals, the d orbitals, and the f orbitals. So whenever the instruction says orbital diagram, that means that you're going to be filling electrons into boxes. So once again, this handout from last class, you're going to want to have it out. Do you have your handout from last class?
I was trying to join in.
Okay. All right. So utilizing the handout from last class, the order of filling electrons is going to be the same as it was into sublevels. So where would we begin? So look at here. What's the correct order? You start at 1s. But instead of simply just writing 1s, you actually write 1s with its box. And so write it like this. Follow along. 1s and then a box. Usually we write the notation underneath the box to save space instead of writing it on the side. And we also don't write the boxes bottom to top because it takes up a lot of space. We just write them left to right. The same way as if you were doing the filling into sublevels. And so this 1 box represents the 1 orbital. How do I know that 1s has 1 orbital?
Because it has 1 box.
You're supposed to memorize that. S comes in a set of 1, P comes in a set of 3, D comes in a set of 5, and F comes in a set of 7. That was from the first lesson. That is something that it is actually expected that you're going to have to memorize that. That's why I said all the information here you are gonna have to know because it does incorporate what we've learned the past several lessons. So 1s. How many electrons? The way you think of step 1 here is again, it's always the same thing. Step 1 would be to do what? Before I start filling in the boxes, I have to know what?
The rest of the.
Find argon in the periodic table.
I have to go find argon, and then I have to find its what? Right. So find the electrons. I need to know how many electrons I need to place. And this is going to be 18 because argon is 18. So now this comes to what we have to recognize. Electrons are going to be represented as arrows. And in every box, you're going to have one electron as an arrow up and one electron as an arrow down. So in this 1s box, you can only fit 2 electrons. One is an arrow up and one is an arrow down. So the same way that before you would have just written 1s2, now you're writing the 2 electrons individually into the orbital. You're saying in that orbital fits 2 electrons. So out of the 18, how many have I used? Same strategy as last time.
2.
So now I have how many electrons still left to fill? 16. Now we're going to go to the next label, energy level and sublevel. So if you need guidance on that, you can go back to the chart. That's why I told you to take it out. After 1s comes
2.
2s.
2s. And how many boxes would that be?
1.
Right. And how many electrons can fit there?
2.
So we put 2. 1, 2. How many electrons do I have left?
14.
14.
14. So I move forward. You see, I'm just crossing out the numbers as I go along until I run out of electrons. After 2s, we're going to keep going back and forth here. We go to 2p. And now I do expect you to know that 2p has how many orbitals? 3. And 6 electrons. 3 orbital boxes, though. So you would write for 2p, 3 orbital boxes. And you can write, like, you know, that all belongs to 2p. Or I usually just write 2p under the 3 boxes, and it's implied those 3 belong to 2p. And we want to put 6 electrons there. So here's where you have to be careful. It doesn't matter here, but it will matter in aluminum. It'll matter later. When you fill the electrons along multiple orbitals, you're actually supposed to fill them in the following way. So pay careful attention. This is Hund's rule. Hund's rule says you have to place 1 electron in each box first, up, 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 and then you place the electrons down, down, down. It doesn't matter for this example because it's going to end up being the same regardless, but it will matter in other examples actually, and it matters for bonding later in the class, so you have to get it right. And so Hund's rule says you have to fill 1 into each box of equal energy before you double up. And now I filled 6 more electrons into the 2p. How many electrons do I have left to fill? You subtract 6 from 14, you're allowed to use a calculator. It's early in the morning, no calculator shame. 8. 8's what you have left. We're going from 2p, where are we going next? 3s. How many fit there?
2.
And so we do an arrow up and an arrow down to represent 2. We've got 6 left. Where are we going next?
3p.
And then we put 1, 2, 3. 1, 2, 3, 4, 5, 6. And that's it. We've done the orbital diagram. So the orbital diagram basically places the electrons into the orbital boxes. Now, aluminium is kind of simple. I think instead of aluminium, I'm going to do silicon. You're like, well, they're right next to each other. But I have a reason for changing this. I'll probably just erase it and change it for the other classes to silicon. Because I want to show you Hund's rule. Aluminium doesn't really show it, but silicon will. Let's do silicon. How many electrons does silicon have? 14. So step 1 is always going to be find electrons. We have to find the amount before we can start placing them. So find electrons, this equals 14. And so take out your chart again. Where do we start?
Oh, one is.
1s. And now we're going to write the boxes. When I see 1s, I need to know it's one box. S is 1, P is 3, D is 5, F is 7. When we look at orbital boxes, which is just the amount of orbitals. 1s, how many electrons there?
2.
Subtract 2 from 14, you have 12 electrons left to place. You go to 2s. How many electrons, how many boxes? 2 electrons in 1 box. So 2s2. You have 10 electrons left. You go where next? 2p. 2p has 3 boxes because p always comes in a set of 3 orbitals. And how many electrons? 1, 2, 3, 4, 5, 6. 4 left. We go to 3s. How many boxes here?
One box.
1 box, 2 electrons. And now we have 2 electrons left. Where do we go next?
Go to 3.
Okay, so I have a couple things to bring up here. This is going to be the last section because we only have 2 electrons left. And so a couple of points of note. First of all, if you write a section, you have to write the whole section, meaning you have to write 3p and you have to write all 3 orbitals, whether or not they have electrons in them or not. So that's the first thing, right? All 3 orbitals because you entered that section. Now, there are 2 electrons left to place, and there are 3 orbitals. How should I place those final 2 electrons?
In one of the orbitals. Like that.
Remember, these are different regions of space, and that electrons are negative and repel each other. So this is what incorporates rule number 3. So I'm going to write rule number 3 here, which is place electrons into separate orbitals
So you have
first.
one going up and one going down.
So one in each, one in one box.
1 in each box, like this. Left to right.
One going up.
Both going up.
No, I thought it did.
Both
Oh,
going
okay.
up.
One was going up, and the second box one was gonna go down.
Up, 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 then down, down, down. So the order is literally up, 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 and then down, down, down. If you want to, left to right, the order is up, 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 down, 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 like that. If you have 3 boxes to fill. This is Hund's rule, which is that electrons repel each other, so they end up being in separate orbitals. So you face all your electrons up into separate boxes first, and then you double up. So place 1 electron in each box before putting 2 in any box. That's the idea. So be careful with that. That's why I wanted to show you silicon instead of aluminum, because it illustrates Hund's rule, whereas aluminum wouldn't have done that. So make sure you have this as your answer here for silicon, and then we'll continue. So key points you need to get. Orbital diagram means you're using boxes. The order you're actually going to be able to come up with from the periodic table, but knowing how many boxes are for S, how many boxes are for P, for D and F, you've got to memorize. That's the material from lesson 1. Knowing S comes in a set of 1, P comes in a set of 3, D comes in a set of 5, and F comes in a set of 7. All right, so this was orbital diagram. What can make this easier or more difficult is just how tedious it is, how long the electron configuration is. The practice examples here were for 18 and 14 electrons. If you had something that had 50 electrons, you'd have a lot of boxes to fill. And so let's do one more, iron. Try this one yourself. So this one, try this one yourself first. I'm going to give you a couple of minutes to try it yourself. Use the order, use the paper, because I haven't taught any other way yet. Use the paper in front of you to figure this out. See if you can write the orbital diagram electron configuration for iron. question? So I'm just giving you a jump on this one. See if you can try it yourself first. I'm going to start solving it in a minute. I will solve it up in the front, but I want you to check to see if you got the idea, if you got it right or not. So that's why I'm pausing. I'll start working it out at 8:22. I will tell you, hopefully you found the correct amount of electrons to place. That would be 26. 26. Okay. I'm going to go ahead and start working it out, and you can see if you got it right. The first place to begin here is always at the beginning, 1s. So I start at 1s, and then I write my 2 electrons, 1 up and 1 down. Then I go to 24 left, then next 2s. 22 left, then 2p, which you should fill with 1, 2, 3, 4, 5, 6. Left, F. 14 electrons left, go to 3p. There's a little cut there, so I have to go left, I go to 4f. There, I go to 3. So you should have ended in 3D here. 3D you're supposed to write out 5 orbitals. I've got 6 electrons to place into 5 orbitals. So the way you do this is up, 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 up. 1 electron in each first. Up, 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 up. And then left to right 1 electron down. You've only got 6 to place. I already placed 5, so it would look like this. This would be I. Where are you heading? Okay. All right, so that's orbital diagram. That's how you complete orbital diagram. This will be part of what's on the quiz on Friday. So the next thing that we need to cover is how to use the periodic table, I believe. We are finally to the point where we can use the periodic table to do electron configurations. Yeah. All right, while I'm waiting for you to wrap up on checking to see if you got the same thing as I did, make sure you label this 3D. I'm passing out a handout. It is another periodic table. This one you're going to do very something specific with, what you're going to use the colors for. And we're going to diagram this periodic table for electron configuration. Yes, the periodic table is going to look exactly like room 1 that is at the table because I like to use the Cambridge credit table. Alright, so this right here coming up is something extremely important for you because this is the strategy you're actually going to use. Unless you want to memorize the whole pathway, this is the strategy you're actually going to use to be able to figure out electron configurations. So, turns out, and you don't have to write anything yet, that your periodic table can be split into 4 areas. S, P, D, and F. And it turns out that these first 2 groups or columns that are on the left-hand side, they actually can represent the S block, meaning that all elements that end there end their electron configurations in S. Everything in the middle here, this middle part of the periodic table, every single element that's in there will end its electron configuration with D. Look at iron. Where did D end? Where is iron? It's right here. It ended in D. On top of it, not only did it end in D, it was the first, second, third, fourth, fifth, sixth element, and it ended in 3D6. Actually. The P block over here, if you look at argon, which we just did, argon ended in 3p6. Guess what? This is the P section, and 1, 2, 3, 4, 5, 6. 3p6. So actually, the whole entire order of electron configuration can be found within the periodic table, and that's what I'm about to teach you now. Once you figured out, once the light bulb goes off, you're probably not going to want to do this a different way, because it is by far the easiest way to do electron configurations. And so there is another note here, and I do have this for you. I'll have this printed out for you. Each period on the periodic table, which is a row, we call it rows periods. That's actually going to be in our second half when we do a deep dive in the periodic table. We're going over all the parts of the periodic table, what they're called. But for now, just so you know, periods, they're the rows. They actually represent a principal energy level. So for S and P elements, you can actually look at row they're in, and it'll tell you their highest energy level. D and F gets a little bit more complicated, and so I'll bring up what you have to do here shortly. But let's go ahead and start working on diagramming the periodic table. So I told you were going to get 4 colors. I've just printed out a periodic table for you. Hopefully you had gotten those 4 colors when I asked. On the top of this periodic table, I want you to write electron configuration, so you know what this periodic table is supposed to help you out with. It's to help you visualize electron configurations. And you're going to pick your 4 colors. You're going to pick 1 color for S, 1 color for P, 1 color for D, and 1 color for F. And so what you're going to do is shade in, pick your first color. I'll choose red for mine. And you're going to want to highlight in your F block. So pick a color, and then you want to shade it in lightly. Your S block. Hydrogen and helium, unfortunately, are also in your S block. So you should shade those 2 elements in the same color, because those are the elements 1 and 2 in period 1. So start with that. S block, you could also write it here if you prefer. S is group 1 and group 2 of your periodic table. Welcome back. Now, when you're done with that, I'm gonna pick a different color. So I'm gonna pick a different color. I'm gonna pick blue. And now groups 13 through 18, and yes, this is the older periodic table. So this whole section here, and then you want to shade it in. Not so you can't see the elements, but just shade it in. We call this our P block. And if you count the groups, S has 2 elements, P has 6 elements. Those numbers have relevance to us? S has 2, P has 6. Count the elements in the next section, which is going to be the D. How many elements is that? 10. D10. Does that have any relevance?
Yeah.
Those are actually the amount of electrons per each sublevel, right? It's in the periodic table. It's told to you in the periodic table. So I'm going to pick a third color. I'm going to pick like orange. And I'll do my V block, which are all of these elements. And actually, it's all of these. There's a little bit of crap. All of these elements. And this. It's all my V block. I do want to point out lanthanum and actinium should actually be right here for this Cambridge periodic table. I don't know why, because I think it's, well, I guess this one does it too. I don't know why they have it broke off. When I used to study as a student, they were here, LA and AC, on the old periodic tables I had. But this is actually lanthanum and actinium. I think it's because it breaks off after here and goes down. But this actually is in the D block, the elements lanthanum and actinium themselves. Makes it a little bit weird. Then count from 58 to 71 how many elements that is. 58 to 71. 11, 12, 13, 14. 14 have any relevance?
Yeah.
That actually is the amount of electrons in an F block. So this is the F block right here. So this right here actually is enough information to tell you where your element's electron configuration will end. I'll give you some time to fill this in. We've got some more to do, but this gives us a good place to start. So once again, at this point, you should be highlighting either with colored pencils or with markers or with crayons, 4 different colors for your 4 different areas of the periodic table. There's another puzzle piece that's about to come in. The Cambridge periodic table does not number periods. They do number groups, but they don't number periods. So we should do that. Row 1 of the periodic table, this is row 1. This is row 2, row 3, row 4, row 5, row 6, and row 7. You should, on the side, once you're done coloring in, you probably use a pen and write 1, 2, 3, 4, 5, 6, 7. I'll pause again to give you a little bit of time to do this. you a heads up, at 37, I'm gonna keep talking. I'm gonna give about 2 minutes for those of you that are still highlighting. You've got about 2 minutes. All right, don't forget to put in the numbers 1, 2, 3, 4, 5, 6, 7 as well. The next handout that I'm gonna give you, I would like you to write unit 2, lesson 3 on. The handout that I'm giving you, please write unit 2, lesson 3. This actually, if you read this left to right, this is going to teach you how to read the periodic table as if you are reading the lines of a page. You're reading a story. There you go. So again, on this handout, you're going to write unit 2, lesson 3. Notice there's a lot more handouts in this unit. Wrapping up highlighting in. You repeat energy level number 5. Remember, this is the way that we're actually going to do electron configuration. So you want to make sure you get the idea down. Okay. So before moving on, you can actually now, at least for the S&P block elements, you can predict the exact ending of any electron configuration. Meaning, now I can ask you, what is the ending electron configuration for arsenic? All you would have to do is look at the row it's in. That tells you its principal energy level. So what would the energy level for arsenic be? Arsenic ends in what energy level? 4. 4. Then you would find its sublevel by finding what section is it in. Arsenic is in what section? SP, D, or F? P. And then you count the boxes left to right until you reach arsenic, starting at the first one of P. The first one of P is here. So P1, P2, P3. I know now that the ending of arsenic must be 4P3. And then I would just fill in everything before that.
So how do you?
The row.
Oh, okay.
It's in row 4. It's in section P. It is the third element over. Let's take a look at fluorine. See if you could try it again. The ending of its electron configuration. What row is it in? 2. The section is P. And it's which element over? 1, 2, 3, 4? We know it ends in 2p5. And everything else before that would be filled in, which we're going to go over shortly. So once it clicks, this is actually by far the easiest method to use to come up with electron configurations. Now you'll notice this paper handout I gave you. It brings up a very important point that you're going to need to memorize. I'm going to go back to it here. Remember that in the off-bulb principle, there was a couple of places where things got weird. After 4S, you need to memorize whenever you enter D, you always have to subtract 1 from the row. So that's going to look like this. If this is row 1, row 2, row 3, row 4, row 5, row 6, and row 7, every time you enter D block, you have to subtract 1 from the row. So that means that this is not 4D, this is actually 3D. And you might want to write that little note for yourself. 3D, 4D, 5D, 5D, and 6D, like that. Whenever you enter D, remember that weird little thing where it reverses? We went over last class. You go and you subtract 1 from the row in order to get where your D's are at. So that gives you the order. That's why I have it on this paper for you, just in case you forget. I printed it for you. So you have 4S, then 3D. All right, and then F gets really weird. You won't be really tested on F very often. Cambridge doesn't test F at all. But it could show up, you never know. You get an element you want to study like uranium, it will show up. And so in the F block, what you have to remember is that this actually is a subtraction of 2 from the row. So what does that mean? Whenever you enter 6S, you actually go to 4F. And whenever you enter 7S, afterwards you go to 5F. So you're going to want to point that out. Just in case you get an F block that you have to do the electron configuration for. Which, like I said, is uncommon, but not unheard of. Where are there what? Oh, I had mentioned it. It's an older periodic table. That one that's printed is an older one. They are filled in the newer ones. They should be filled in. Actually, they're filled in on this one. And this one's like from 2019. So that one's from like 2016. There were 4 elements discovered in the 2010s, actually. The last 4 elements were discovered in the 2010s.
So for F block, it's 5, 6 and 7, and you just.
It goes 6S, then 4F, and then 7S to 5F. That's the lanthanides and actinides. Look, that section. So for D's, you have to subtract 1 from row, and for F's, you have to subtract 2 from the row, actually. So this is what you should have filled in. You should have this on top of you, like with you. And we're going to start to use these in tandem to help us read electron configurations off the periodic table. And so taking a look at both, well, first of all, see if you can answer these based on what I have already taught you. It asks you, what element ends in each of the following electron configurations, starting with 4p4. Can you figure this out? Okay. No, agree. What's 4p4? So imagine before today, if I asked you this question, you would have had to go to that paper and go 1s2, 2s2, 2p6, 3s2, and add it all up. But now with the periodic table, you can go do what? Go 4,
Selenium.
go to p, and count over 1, 2, 3, 4, and the answer is
Selenium.
selenium. That's correct. Yes. To this one. This is the one, the handout you have. All right. 5s2. 5s2. What's that? 5s, and it's the second one over, so it's straddling. So instead of having to write the whole entire electron configuration, you just go and figure out the 2p3. 2, that second row down. P, this section. 1, 2, 3. Nitrogen. So it's basically like its coordinate, you can even think of it as. So are you going to have to memorize the S, P, D, and F sections of your periodic table? Yes. This is what you're expected to memorize, is the sections of your periodic table and how to read it. What I've given you is visual ideas on how to do that. 3d6. All right. When I go to 3, I don't see D. What's going on? When you go down to 3, D's not there. What's happening? I don't find 3d6. Remember that 3D is actually found in the 4th row. You have to actually remember that. So 3D is found in the 4th row. 4D is found in the 5th row. You always have to subtract 1 from the row to get your D section. So this is actually 3D right here. The 6th element would be 1, 2, 3, 4, 5. Iron. The answer here is iron. That's what you do if you're looking for an element based on its end electron configuration. Which means if you're given a gigantic electron configuration, you just look at the last part, and that can tell you what element you have by looking at its position on the periodic table. All right, so now what you're going to have to do, and I left this up here to help to learn how to read it, is give the electron configuration for each of these elements. And so when we say electron configuration with no other directive, this means fill into sublevels. This is 1s2, 2s2, 2p6. That's what we mean by this. So write the electron configuration for. There's 3 examples here. Let's go ahead and see if we can use the periodic table now to figure this out. So write the electron configuration for. You need to write down these examples in your notes. The first one is beryllium. And whenever you're asked for write the electron configuration and you're not given any other directive except electron configuration, this means the format is to fill into sublevels. The normal way to do electron configuration is like 1s2, 2s2, 2p6, that's it. So let's see how we can use our periodic table to help us with this. And so it's not just the last energy level we want the whole entire electron configuration from the periodic table. Okay. That's the end of it, but you just have to give the whole thing. That's the end of it, but you have to give the whole thing. All right, so let's remember, if you're asked for an electron configuration, you have to start from the beginning. Where's the beginning? 1s. And so the way that we use that interpreting the periodic table is we're actually going to read elements left to right until we get to the one we want. And so beryllium has how many electrons?
4.
So I'm going to start with that. It has 4 electrons. Before beryllium's here. That's where it's at. So the way that we do this is we read each row, starting with row 1, left to right, and we count elements until we get to the desired element. And so to get to beryllium, I first have to go through row 1, which is hydrogen and helium. There are 2 elements there, so we say 1s2. 1s2. There's 2 elements there. After 1s, I go to 2s. And beryllium is the second one. So I stop at 2s2. You still have to fill 1s before you fill 2s. And so this would be the 4 electrons. You fill the first row, and then in the second, you got to the second element. 1s2, 2s2. If it doesn't click after all the examples, the other way to do this is just to memorize the order. But if you can figure it out with the periodic table, it is by far a simpler manner to go by. It's less to memorize. Fluorine. We want the electron configuration for fluorine. That's just how many electrons it has. That's these. 2 plus 2 is 4. Fluorine is how many electrons? 9, right? And it's here on my periodic table. So I know just by looking at this, I know where it ends, but I have to fill all my earlier energy levels first. So do I start? 1s. And you have to fill 1s before moving on to 2s. And then you have to fill 2s before moving to 2p. 2s fills at how many electrons? 2. And then we know at the last one, where fluorine's located, 2p, we count boxes until we get to fluorine. Fluorine's which box? The 5th. So we ended at 2p, 5. And then 5 plus 2 plus 2 is 9, right? It works. So note what I'm doing. I'm locating the position of the element on the periodic table, and I fill everything until I get to that element. From left to right, row to row. Try gallium. Let's see that one. That's the hardest one here. Where's gallium? It's,
4P.
we know it's 4P1.
31.
4P1. We know that that's where it ends. But now we have to fill everything before that. So going to 4P1, the idea is that everything before that has to be filled. That means you have to go through all of this to get to 4P1. So where would you begin?
1s2.
So we know this is 31, right? We're going to begin at 1s2. After 1s, we go to 2s. We know everything has to be full until we get to the final area. S fills at how many? You can just count the elements or memorize it's 2, right? You fill 2s, then you go to 2p. 2p, how many? 1, 2, 3, 4, 5, 6. Then you go to 3s. 3s maxes out at 1, 2, right? You count boxes, basically, and that's telling you how many electrons you fill up to. After 3s, you go to 3. You're reading left to right. So after 3s comes 3p. 3p right here. Remember, there's an empty section at the top. 3p, how many? 1, 2, 3, 4, 5, 6. After 3p comes 4s, 2. After 4s comes 3d. 3d would max out as well, 3d10. And then you end at 4p. And it's the first one. This is gallium. So you can get the entire order from the periodic table, reading left to right, row by row. You will have to memorize using the periodic table to figure this out. As long as you can memorize your sections are S, P, D, F. You memorize your rows 1 through 7, and then for the D section to subtract 1, you would be good. That's what you have to memorize in order to do this strategy. Other than that, you memorize the whole order: 1s, 2s, 2p, 3s, 3p. That's the other method. I would suggest using the periodic table. I suggest it. All right. So I think the last part of today's lesson you will really like. The last part of today's lesson I think you will really like, because it's called shorthand electron configuration. So instead of having to write elements like uranium and filling 92 electrons into sublevels and boxes, we can utilize something called the shorthand electron configuration. So write this title in your notes, shorthand electron configuration, and write the example. And I'll explain what this means. Now that you know how to use the periodic table to come up with electron configurations, you don't have to write your inner energy levels. You don't have to write the core electrons. If you know how to use the periodic table, you can utilize a strategy called shorthand notation. What you do in shorthand notation is you look at the last noble gas. That would be the last P6 group before your last row. And instead of writing, in this case, 1s2, 2s2, 2p6, 3s2, 3p6, you just replace it with that element, with the last P6. This is where the noble gas, group 18, element you would replace with. And you just say that that's argon. So instead of writing 1s2, 2s2, 2p6, 3s2, 3p6, you just say, well, we'll start at argon. That's the 18 electrons. And then the last section, to get to where I need to go for calcium, is 4s2. So I just write argon and then 4s2. And that's called the shorthand notation. I'll give you some time to write this down and we'll take a look at some examples. So I'm about to move forward. I'm just giving you a 20-second heads up that I'm moving forward. All right, here we go. So how can we utilize this strategy? And like I said, once you get what it's telling you, you won't want to do this another way. And some of the questions for the actual unit exam, you will be able to just use shorthand notation. I'll let you know. But there will be at least one question where you have to show all the different types of notation, which is what your homework's going to look like today. So let's take a look at the instructions. So it says write the shorthand electron configuration. So shorthand is your keyword that you're using noble gas. For the following elements. So we're going to start with nitrogen, which really doesn't save you too much space, but when you get to later elements, this is definitely the strategy you want to go with. We'll start with nitrogen, and then we'll ascend to more difficult elements. So what does it mean to use shorthand? You're going to look for nitrogen, you're going to replace the inner energy levels with the last noble gas. So for nitrogen, the way you would do this is you would look at the group 18 element that comes before nitrogen numerically. What is the last element before nitrogen that's in group 18? All those noble gases. It would have to have less electrons than nitrogen. So it has to be what? Helium. So we start by writing helium in brackets. And so basically we say, okay, so the inner electrons, helium, then we start at just this last row. And we write the electron configuration for just the last row. To get to nitrogen, I first have to go through this section. What section is this? Looking at your periodic table that you've notated. This is 2s. Is it full? If you haven't reached nitrogen, then it is full. It would be 2s. You would write 2s and 2, because you filled it. 2s2. And then you move on. You need to get here. What section is this called? Energy level 2, section P. So you would write 2p and how many? How many electrons are there? 2. 1 for boron, 2 for carbon, 3 for nitrogen. So it's 2p
3.
And that's it. That's the shorthand for nitrogen, which really isn't that short. But like I said, it'll help you when you get to farther elements. The farther you go down the periodic table, the better this technique is for you. Magnesium even is better. Take a look at magnesium, see if you get the handle of this. Look for the last noble gas before magnesium, which is the last element that's in group 18. What is it? So instead of writing all of the stuff up through neon, which would be 1s2, 2s2, 2p6, you just write the element neon in brackets. So you look for the noble gas before magnesium, which is neon. You write it in brackets. Then, moving past neon, you just go to the last row of the periodic table that it's in, magnesium. It's in this row. What is this section called? And the energy level? 3. So you have to include the energy level, you have to include the subsection, and you have to count till you get to magnesium. 3s, what? 3s2. That's the shorthand notation for magnesium. Neon 3s2. So now that strategy that I taught you of looking where the electron configuration is ending comes into play. Because here you only use the last section. We'll keep looking at a few more examples. We're almost done. Yeah, this is the last slide. Write the shorthand electron configuration for the following elements. There's 3 more. Like I said, sending in amount of electrons. Titanium, germanium, and barium. We're actually almost done. Once we get through this, and actually I think for that, let me check your homework. I think I will ask you I will ask to look at your barium. So I'm going to do A and B, and I'm going to check for your C, that you can do the shorthand for C. And then I'm going to give you the homework, which you should get started on. I'll explain it, but you should get started on it before leaving so you get a handle on what you need to do. Write the shorthand electron configuration for the following elements. First one, titanium. First step, find titanium. It's right here. What would the last noble gas be for titanium be?
Argon?
So we start by writing argon. And if you want to, you could for yourself say, oh, okay, that's 18 of the electrons, right? 18 of the electrons, and we said that's just argon. Titanium has how many electrons? 22. So how many do I still have left to place? Think about it like that. We still have 4, right? So what comes after argon? What's this? 4s2. Because we filled it. We filled that section. And then titanium's here. Don't get trapped. What is this?
3.
3D, right? Every time you move to D, you have to subtract 1 from the row it's in. So this is 3D, and if you forgot that, I have that here. 4s goes to 3D. You have to remember that. It goes 4s, then 3D. You always have to subtract 1 from the row when you enter D. So 4s, 3D, how many electrons go there? The second element over, so it's 3D, 2. That's the shorthand for titanium. Argon 4s to 3D2. All right, what about germanium? Germanium. What's the last noble gas before germanium? Argon again, right? But now we gotta go farther into the next row. Argon, after argon, we go here. What is this? 4s2. Then after 4s, we go to 3d. Do we fill that whole section?
Yeah.
Yes. How many electrons will fill D? You can count across, but you are supposed to memorize it is 10. And then finally, germanium is in this section. This is 4p. And how many electrons over it? 2. Germanium 4s2, 3d10, 4p2. Quick question before we do the last one valence electrons would be there for germanium? How many valence? 2. Nope. Valence electrons are the electrons in the outermost energy level, not the outermost energy sublevel. So you have to look for the number 4. How many electrons are there? 2 and 2 more, right? These 2 and these 2. The 3d10 is in an earlier energy level. So the amount of valence here would be 4. I'm bringing this up because when I give you your homework, one of the things I'm going to ask for is actually a simple electron or an electron arrangement. And in order to be able to do an electron arrangement, you have to figure out how many electrons are in each energy level. So if I were to give you an electron configuration for germanium, a full one, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p2. That's the full electron configuration for germanium. How would you place the electrons into energy levels? How would you do an electron arrangement? Right. Third one you'd have is 18, and the last one you'd have 4. 2 electrons for 1. Energy level 2 has 8. Energy level 3 has 2 plus 6 plus 10, 18. And energy level 4 has 2 plus 2 is 4. You're going to be asked to do this in your homework today. So that's why I wanted to bring it up. When you're arranging into energy levels, you're arranging looking at the numbers in front here. The numbers in front are the energy levels. When you're filling electrons into energy levels, you do it like this. So you have one question to do, shorthand. Barium. See if you can do it. Raise your hands if you have it ready for me to check, and I'll check it. And I also have your homework. You've got some time, so you should start working on it so that you can ask questions if you get confused before you leave. Like I said, if you are done with barium, raise your hand, and I will check it off as I'm coming around and giving homework. And like I said, the homework today is actually what the written part of your quiz on Friday is going to look like. Just different elements or ions. Correct. I will come back if you hadn't finished it the first time I had passed by. Yeah. Okay. You add 2 not 10. I'm passing out the homework. If you do not have the answer for barium, I'll come back by. Is that one's correct. Okay. Somebody's not right now, please. Your question, I'm looking for barium. Alright, once again, if you have barium done for the shorthand, let me see it. Did you get a copy of the homework? So 6. Sabina's right. 6 what? Here. That's S. 6S. And how many electrons would it have in 6S? You'll notice for the homework, I filled in an example for oxygen just to show you what each version looks like. What is an electron configuration? What is the shorthand? What is the orbital diagram? And then what is the simple electron arrangement? Make sure you're getting started with it. You don't need the fact. On the homework, I showed an example of what I expect at the top. Make sure that you are using that to reference for the different types of answers you are going to be asked to give. For the crayons and the colored markers, leave them on the napkin that I left at the table for the next class so that they don't have to continually go back up and get crayons or markers. So if you borrow my crayons or markers, please leave them on the napkin for the next class period.